Today, I'm going to be going over kinematics in 2 dimensions. Specifically, we're going to be going over a common physics problem, which involves a soccer player kicking a soccer ball. We want to determine how long does the ball stay in the air, we want to determine the maximum height reached by the ball, and we want to determine the horizontal displacement. So how far does it travel horizontally before hitting the ground? And all of this is going to be done today using two-dimensional kinematic equations. The first one we're going to need is for displacement based on time. So this is x of t equals x naught plus v naught times time plus 1/2 acceleration times time squared. The important thing with the soccer ball problem is that we have both a vertical and a horizontal displacement. So we can break this up. We have x of t, we'll call this our horizontal displacement, but we're also going to have y of t being y naught plus v naught y, so initial velocity in the y direction, times time, plus 1/2 acceleration in the y direction times time squared. And then I'll put an x on both of these to show that the top one is worried about horizontal displacement and the bottom one is worried about vertical displacement. For our axes, I'm going to set this point at the ball to be 0, 0. So in both cases, x naught and y naught are both 0. So I'm not going to worry about them. Once the ball reaches the ground, there's going to be no acceleration in the x direction. So since this term a sub x equals 0, I'm also going to erase this term. There is, however, acceleration in the y direction. This is gravity. If you're having trouble with realizing when something has acceleration and when something doesn't, you can think to yourself, what forces are acting on the ball at this moment? The equation for force is F equals mass times acceleration. So if you're thinking, what acceleration does this object have in this specific direction, think, is there any force acting on the ball at this time? So let's say the ball is in the air over here. There's gravity acting downwards, but other than that, there's nothing actually acting on the ball. It has some initial momentum given by the kick from earlier, but it doesn't have actually any acceleration in the x direction. So the acceleration in the y direction is due to gravity, and this is 9.8 meters per second squared. The next thing we're going to need is v naught x and v naught y. Let's say that v naught equals 20 meters per second, and this theta from horizontal equals 30 degrees. Using trigonometry, we can calculate v naught x and v naught y. So we have v naught here, we have 30 degrees here, so we know that over here is v naught times sine of 30. I like to put my v naught first. And then down here is v naught times cosine of 30. This is just our basic trigonometry. V naught is a vector. It is the velocity vector in that direction. So this is the velocity vector in the y direction, and then this is the velocity vector in the x direction. So we know that v naught x equals v naught cosine of 30, and v naught y equals v naught sine of 30. And since we know v naught and we know theta is 30, we can plug both of these in to solve for v naught x and y. So we know that this is going to equal 20 times sine of 30, and this will equal 20 times cosine of 30. If you'd like, you can calculate these out and plug them into your equations now. When I solve physics equations, though, I like to leave it like this so that I'm dealing with less decimals, and then I plug everything into the calculator all at once. So our new equations for x of t, recall that it was v naught sub x times t. So now it is cosine of 30 times time. And then y of t equals 20 sine of 30 times time plus 1/2 acceleration in the y direction, which is 9.8 times time squared. So these are our full kinematic equations for the horizontal and vertical displacement. Now that we have both of our equations for the x displacement and the y displacement, we can go back to our initial questions and we can start to solve them. So let's look at question 1. We have, how long does the ball stay in the air? Something key to realize is that, well, let me draw the path of the ball. Here's the ball at t equals 0. You're going to kick it, and it's going to do something like this. And then here's the path, or it hits the ground over here at t equals something. If you draw this as an x and y axes, you realize that it starts at this point, y equals 0 over here, and then over here, y still equals 0. And so you can solve y of t for when it equals 0. And you'll actually end up with 2 times. And I'm going to show you how now. So we say y of t equals 0. And this equals 20 sine of 30 times time plus 1/2 times 9.8 t squared. This is a quadratic equation, and you can use the quadratic equation to solve it if you'd like. Or you can realize that both of these have a t in them, and so you can factor out the t. So now 0 equals t times 20 sine of 30 plus 1/2 9.8. I realize I've made a slight error. Since 9.8 is negative, all of these should be negative. It's a negative acceleration. It points towards the ground. But it's minus 1/2 9.8 t. And you can see that this gives us 2 values. Y of t equals 0 at when this t equals 0, so t equals 0, and when this inside portion equals 0. This makes sense because we have a point right here where it equals 0 and a point right here where it equals 0. So we have 2 t values. We're interested in the final one. We already know that this one here is 0 when t equals 0. So if we solve this inside portion and we set that equal to 0, it'll give us our how long the ball stays in the air. So let's go ahead and do that now. We have 20 sine of 30 minus 1/2 9.8 t equals 0. So now we need to get the t by itself. We can add 1/2 9.8 t to both sides. You get 20 sine of 30 equals 1/2 9.8 t. To get t by itself, you can multiply both sides by 2. That'll get rid of this 1/2. And then divide both sides by 9.8. So that gives us our final value that t equals 2 times 20, which is 40, sine of 30 all over 9.8. Let me plug that into the calculator real quick. So once you plug this into the calculator, you get that it roughly equals 2.04 seconds. So I'll write that up here. Let me move this out of the way. There we go. Okay, next question we want is the maximum height. We've already determined that it's going to take 2.04 seconds for the ball to travel its total path. And we can determine the maximum height by again returning to our diagram. If you realize this is it follows a very nice quadratic arc. This makes sense because if you look at the equation for y of t here, it is a quadratic. And so we want the time at this point, which will give us our y max. If you realize that's right in the middle of the arc. So if we take this time 2.04 and we divide it by 2, we'll get the time at which the ball is at the maximum height in the arc. Now 2.04 divided by 2 is 1.02. And so we can use this time and plug it into our y of t to find the maximum height. So let's do that now. We have y of 1.02 equals 20 sine of 30 times 1.02 minus 1/2 9.8 1.02 squared. This is just an equation you can plug into the calculator. So I'm going to plug that into the calculator real quick. So the value that I got is that y of 1.02 equals about 5.1 meters. Remember, our units are meters. We're doing things V0 is meters per second. You always want to do your equations in meters. But we'll say that our maximum height is 5.1 meters. So now we'll do the horizontal displacement, and we'll use really the exact same method and plug it in for x of t. So we know that over here we have y equals 0, and this is the end of the arc. And we found earlier that the time at this point is 2.04 seconds. So we can plug that into the x of t equation we derived earlier, which is 20 cosine 30 times time. So we can do x of 2.04 equals 20 cosine of 30 times 2.04. I plug that into the calculator real quick. You get a value that's about 35.3 meters. And that is the end of this problem. I do want to say one quick thing though, that the way that I solve this problem is not the only way to solve the problem. There's a few more kinematic equations. The ones that I chose to use are traditional for solving for position when you need to find time. But if you have less information or, say, different information, you can use a different kinematic equation. For example, you could also use the equation, I'll write it down here. I'm going to erase this to give myself some room. You can use the equation that v final squared equals v initial squared plus 2 times acceleration times delta y, or delta x, whatever direction you're solving for. So given that we know that at this y max, the y velocity, since it's changing direction there, would be 0, you could say that 0 equals v initial in the y direction squared. And this 0 comes from, we would solve for the final velocity at the top of the arc, plus 2 acceleration in the y direction times delta y. And then you could rearrange this equation. We found v initial y earlier. We know the acceleration in the y direction. So you could rearrange this equation to solve for the change in y at the maximum point, which would give us our maximum height of 5.1 meters. I'm not going to do that, but I just wanted to illustrate how you can solve most problems in many different ways. So don't feel bad if you're practicing a specific way more than others. You'll really get that way down, and you'll find it to be a great help to you.